But we attained this by simply looking at the data and making judgments. We're just, this is the second place that, at least the second place where knowledge of conditional independence might come from. It might come from what I would just call first principles. We reason about the domain as experts, as people who know about the domain. Here's an example. Suppose the groundskeeper set the sprinkler timers on a fixed schedule, and the fixed schedule is going to vary summer, winter, spring, fall. There's also some probability it will rain or not, and that probability that it will rain is also dependent on season. So in that kind of circumstance where a groundskeeper is setting a schedule, a priori, this might be the Bayesian network that reflects that situation. Whether the sprinkler go off is associated with the season and the schedule associated with that season. Whether it rains or not is associated with the season. This is why, and this is probably an accurate model of the way it works, because you'll go outside often enough and it's raining, and sure enough the sprinklers are going on, and there's a downpour. So clearly these are independent. This is not a Bayesian network that I would use to represent a homeowner's behavior. A homeowner is probably going to be doing watering or turning on the sprinklers based on both the season and whether it's raining. This would be the Bayesian network that the homeowner would use. So different Bayesian networks for our different principles and for first principles and different tasks. So here's here's an interesting example, since we're working with courses, and this is actually something you might consider for the second deliverable, not this deliverable. But if you think about CS courses, I've just highlighted some courses that we all know about: Introduction to Computing, Computing and Society, Data Structures, Discrete Math, etc. That's the Project in AI class. Construct a Bayesian network for predicting grades of certain courses called query courses or query variables. These are the variables you're asking about. From known or assumed grades in other courses. So can you predict the probability of an A in CS3 250 given an A in CS 101, 151, and 201 and 212? Let's say that somebody has had those 4 classes, and we want, or let's say they've had these 5 classes, and we want to use their grades from these 5 classes to predict the grade for CS 3250. Okay, so if somebody got an A, a C, a B, an A, a B, what would be the probability of their getting an A in 250? What would be the probability of getting a B in 250, a C in 250? There's probably other factors that affect grades that this doesn't take into account. Okay, stress, workload, things we all know about. If you were just restricted to this evidence, what would a Bayesian network look like? And I want you to pull out a piece of scratch paper for that. And I want you to scribble out what you think a Bayesian network might look like for that set of courses. Go ahead and do it. If you're online, do it there too.